Find points on the lemniscate where tangent is horizontal or vertical. Well, it's somewhat helpful if you know the graph, although you can still solve the question without knowing the graph. I used a website called Wolfram Alpha to generate the following graph. That's what it says. And we already see that there should be like 4 points where you have 1, 2, 3, 4 points where you have horizontal tangent lines, and there should be 2 points where you have vertical tangent lines. Okay. How do you actually find that? Well, slope of the tangent line is given by y prime, that we all know. And if it's horizontal, that's the case when y prime is 0. And vertical slopes are undefined, so when you have a vertical tangent line, that's when y prime is undefined. So it boils down to figuring out y prime first. So let's do that. But as you can see, this is a very complicated equation, and you cannot solve this for y prime, and therefore you cannot solve this for y, and therefore you need to find the y prime using implicit differentiation. So that's the first tricky part. Let's try that. Now, in implicit differentiation, x and y are treated differently. X is just x, whereas y is considered as a function of x. And you're trying to differentiate both sides by ddx. In other words, you're treating both sides as functions of x, and you're differentiating by x. And because there's a choice in which derivative you're taking, you're not differentiating by y, you're differentiating by x. The x and y are treated differently. There's this asymmetry between x and y, and that's what confuses a lot of students, but make sure that you understand the difference. X is just x, but y is a function of x. That's the big difference. Alright, so we're going to differentiate both sides. We're going to differentiate the left side. We're going to differentiate the right side. And to make my point clear, here's how you differentiate y squared. Y squared is really, y is a function of x, which you square and you're differentiating, right? And since a function of x is nested inside the square function, you have to use the chain rule, which means 2 comes down, and the inside function must be pulled out, and that inside function should be differentiated. So you know the chain rule, right? Differentiate is a function of y, but then y is the inside function, so you have to pull that out and differentiate. So what you get is 2y, y prime. I'm just not writing down x. I'm using this parenthesis x to stress that y is a function of x, but since we're just trying to do the calculation, it's easier to just write 2y, y prime. However, if you're differentiating x squared is differentiated by x. That's just 2x. Okay, so there's a big difference between these two. Alright, now knowing this, let's continue the calculation. We already did the left side, but so let's look at the right hand side. The right hand side, what's this? That's 2, well, x squared plus y squared is nested inside the square function, so you have to use the chain rule first. So 2 comes down, x squared plus y squared, and then this entire thing is an inside function, so you have to pull that outside, and you have to differentiate this. 2 times 2 is 4, x squared plus y squared, and x squared, we already did that. X squared differentiates to 2x, and y squared differentiates to 2y, y prime. Now, your goal is to try to find y prime, and it really helps when you expand everything. So we're just going to expand this using FOIL. So first, x squared times 2x is 2x cubed. X squared times 2y, y prime is 2x squared y, y prime. Plus y squared times 2x is 2x y squared. Plus y squared times y will be y cubed, so it's 2y cubed y prime. So when you multiply by 4, that's 8x cubed plus 8x squared y, y prime plus 8xy squared plus 8y cubed y prime. Okay, that's your left side. And since the right side, why did I say right hand side? It's left hand side. I'm sorry. This left hand side is this. The right hand side is 25 times derivative of x squared is 2x, and derivative of y squared is 2y prime. All right. So putting them together, this is what I have. I have 8x cubed plus 8x squared y prime plus 8xy squared plus 8y cubed y prime equals to 25 times 2 is 50x minus 50 y prime. Okay. Once you have this, you're done with the derivative. However, you still didn't figure out what y prime is, so you need to do algebra here. So this is the algebra step. The algebra step, you first identify all the y primes, and any of the terms containing y prime should be put into one side. You have to group the y primes together, and the ones without y primes, they should be grouped to the other side. So what I'm going to do is put this, and that together. So I have 8x squared y prime plus 8y cubed y prime, and then this comes to the left side is plus 50 y prime equals to, right, and then you have on the right side 50x should be there. It stays here because it doesn't have y prime. These two terms which doesn't have y prime should go to the other side, so it's minus 8x cubed minus 8xy squared. And then let me change color because it's a little confusing. So then what we get is the reason you group the y primes together is so that you can factor a y prime. So what you get is 8x squared y plus 8y cubed plus 50y y prime. That's on the left side, and the right side is still the same thing, 50x minus 8x cubed minus 8xy squared. And finally, when you divide, you get y prime equals to 50x minus 8x cubed minus 8xy squared over 8x squared y plus 8y cubed plus 50y. Alright, so that's the y prime. Once we get y prime, oh, by the way, this here can be further simplified because both top and bottom are divisible by 2. They're all even numbers. So we're going to divide everything by 2, and that gives you 25x minus 4x cubed minus 4xy squared over 4x squared y plus 4y cubed plus 25y. Okay, so once we have the y prime, now we are ready to figure out the places where you have a horizontal tangent line, right? Okay, so when do we have a horizontal tangent line? That's when the slope is equal to 0. Horizontal lines have 0 slopes, so that means you have 50x minus, I'm not supposed to be using this one, let's use a simplified one, 25x minus 4x cubed minus 4xy squared over 4x squared y plus 4y cubed plus 25y equals to 0. And to simplify this, I'm going to multiply both sides by 4x squared y plus 4y cubed plus 25y. If you multiply this to the left side, the denominator will cancel with this, so you're only going to have 25x minus 4x cubed minus 4xy squared on the left side, whereas on the right side, 0 times anything is 0, so you get 0. Okay, now what does this mean? Well, before you do anything, just think about what you're trying to do. You're trying to find points on this curve where the tangent is horizontal. So you're looking for x comma y. In other words, you need the value of x, you need the value of y. So you have two unknowns. Here we have one equation for the two unknowns. And that's not good, because if you want to figure out two unknowns, you need two equations. You have to have two equations in order to figure out what the two variables x and y are. So as soon as you see this, you should be a little puzzled. So what do I do with this? This doesn't seem to be giving me x and y. I need more equation. And then when you think a little bit further, then you see that, well, I do know that the points x comma y should be a point on the graph, and the graph is this equation. So you see that the graph, the original equation for the graph, is another condition for x and y. So in other words, what you need to do is you have to think about this as one equation, and what we just figured out as the other equation, and you're trying to find x and y that satisfies both. So that's your goal. That's how you find the points where the tangent line is horizontal, or then another one for vertical. Okay, so we're right now only doing the horizontal case. Well, still this is very complicated, so let's try to simplify this. I see that x is a common factor, so I'm going to factor the x out. 25 minus 4x squared minus 4y squared equal to 0. And that's really helpful, because if two things multiply to 0, then either one has to be 0. So either x should be 0, or 25 minus 4x squared minus 4y squared should be 0. Okay. So if you're a detective trying to figure out the bad guys, you now have two leads. And because you have two different leads, you have to follow the track separately. So you have to first think about the first case, case 1, when you have x equal to 0. What does that mean? Well, if x is 0, then this is the condition, one condition, and this original equation is the other condition, so you have to think about what this would mean when x is 0. So you plug in x equal to 0, you get 2 times 0 squared plus y squared squared equals to 25 0 squared minus y squared. 0 squared is nothing, y squared squared is 4th power. And then this is minus 25y squared. I can move that to the left side, and you get plus 25y squared equal to 0, which, if you factor the y squared out, you end up with 2y squared plus 25 equals 0. Again, the same trick. We have two things multiplied, and therefore the first thing is 0, y squared equal to 0, or then you would have the 2y squared plus 25 equal to 0. So what's that? That's going to be oh, this can never be 0, because 2y squared is always non-negative. It can never be negative, right? And you're adding something positive. So this cannot happen. So that means y is 0. And when y is 0, we have some problem here. So in that case, you have x equal to 0 and y equal to 0. That actually makes the denominator 0 also. See, if you plug in 0 in the denominator, you get 4 times 0 plus 4 times 0 plus 25 times 0. So you get 0 over 0. Oh, that's, again, undefined, right? So this cannot be a horizontal tangent line. Yeah. Okay. So what we have is not good. So this first lead was a dead end. Dead end. It didn't give us anything. Now let's try to track down the second case, second lead, which is that 25 minus 4x squared minus 4y squared equal to 0. Now, this is a pretty complicated equation, pretty complicated equation, but if you look at the original, you see that it also has x squared plus y squared. So if you move everything to the other side, you get 25 equals to 4x squared plus 4y squared. And therefore, if you divide by 4, you get 25 over 4 equals to x squared plus y squared. And that's perfect because you're trying to solve a system of equations where this is one equation and that's another equation. And this equation says that x squared plus y squared has to be 25 over 4. So you can replace this x squared plus y squared as 25 over 4. So here's what you get. You get 2 times 25 over 4 squared. Okay, on the other side, 25, well, here it's not x squared plus y squared, so what do? Well, you solve for one and try to get the other value. So you have two options. You can solve for x squared or you can solve for y squared. Let's solve for x squared. So x squared is equals to y squared minus, no, actually, to solve for y squared, you have to subtract y squared. So it's 25 over 4 minus y squared. So 25 over 4 minus y squared minus y squared. See, this much was x squared. So x squared is replaced by 25 over 4 minus y squared, and then minus y squared. For y squared, I don't do anything. And if you look at what we achieved is, now we only have y, right? So that means we can solve this for y. And that's good. Once we figure the y values out, we can use this again to figure out the x values. So we'll proceed. This will be 2 times 25 squared is 625 over 4 squared is 16. 25 times 25 is 625 over 4. And then minus y squared, that's negative 2y squared. 2 times 25 is 50 y squared. And then 2 and 16 can cancel out as 8. And then since I want common denominators, I will multiply 2 top and bottom so that you have 8 as the same thing. Then we can combine these two fractions. I can subtract 625 over 8 to the right side. I can move the negative 50y squared on the left side. So here's what we have. 50y squared equals to 625 over 8. Okay, if you subtract 625 over 4 minus 625 over 8, you're going to end up with 625 over 8. That's because 1/4 minus 1/8 is 1/8. Well, you can just check that this is true. All right, and then you divide both sides by 50, and the result is that after simplifying, you're going to get 25 over 16. And therefore, when you take the square root, y would be plus or minus. Square root of 25 is 5. Square root of 16 is 4. Now, we can't stop here. We have to find x. Remember, x squared is 25 over 4 minus y squared, but y squared is 25 over 16. Now, if we multiply 4 top and bottom, then this will be 100 minus 25 is 75 over 16. So, well, I'll have to go to a new page. So I get y equals to plus or minus 5 over 4. And x would be plus minus square root of 75 over 4. Square root of 16 is 4. That's what you get. And since 25 is a perfect square, 25 can come outside as a 5. And you're left with 5 radical 3 over 4. Okay, so with all this work, you can finally figure out what the points should be that has the horizontal tangent line. It's when, for each y value, when y is 5 over 4, you have either x as 5 radical 3 over 4 or minus 5 radical 3 over 4 And then for the negative value of 5 over 4, you can also have the positive 5 radical 3 over 4 and negative 5 radical 3 over 4. So these are these 4 points. And if you recall the picture, this is in accordance with our picture here, right? So you have these 4 points where you have horizontal tangent lines, and if you have the positive one, the other ones are pretty much the symmetric ones. So you just negate one of the values. If you negate the x value, you get this. If you negate the y value, it's this one. If you start from here and negate both of them, you get this point. So that's how you get all these 4 points. All right. Now what I want to do is now I want to find out when you have a vertical tangent lines. Well, vertical tangent line means y prime is undefined, because vertical lines you have an undefined slope. Okay, so when do you get a fraction undefined? That's when the denominator is equal to 0. So you have 8x squared y plus 8x cubed plus 50. Sorry, that was not x cubed. My handwriting was deceiving me. Sorry, that should be y. So y cubed plus 50y equal to 0. And then you factor the y and you get 8x squared plus 8y squared plus 50 times y equal to 0, right? And then two things multiply to 0, so each individual ones should be 0. Either the first factor should be 0 or y is 0. So again, you get 2 leads, but notice that this is impossible because these are non-negative, so you have something that can never be negative and you add something positive to it, and that cannot be 0. So this can't happen. So the only possibility is when y is equal to 0. When y is 0, and then if you're still using this one, this is what you get. 2 times x squared plus 0 squared equals to 25 times x squared minus 0 squared. So that gives you 2x to the 4th equals to 25x squared. Move it. So you get 2x to the 4th minus 25x squared equal to 0. And factoring the x squared out, you get 2x squared minus 25 equal to 0. Alright, so you either get x is equal to 0. Now this, well, I guess this does require you to look at the graph. See, in the graph of the lemniscate, at 0 you don't have a well-defined tangent line because it's like you can think of this as a tangent, that's a tangent. The graph is like overlapping itself, so there you can't talk about a tangent line. And if you really want to do a tangent line, then you'll see that well, one way to do this is to do parametrization and use some calculus 3 schemes, multivariable calculus, but that's beyond this course. So what happens is that x equal to 0 will not give you any meaningful tangent line as far as in the calculus 1 part. So what you end up with is that you can only have this equal to 0, and that's when you have x squared equals to 25 over 2, which is take the square root, you get plus or minus 5 over square root of 2. So the answer for that is, well, you can rationalize the denominator, multiply radical 2 top and bottom, you get 5 radical 2 over 2. So for the vertical tangent lines, you get it when you have positive 5 radical 2 over 2, comma 0, and another case is when you have negative 5 radical 2 over 2, comma 0. And you recall that those are exactly the 2 points that we're looking for. These are the 2 points. Okay, so that is all.